Good morning, good morning, good morning. At least I think I'm funny. So, guys, I will be with you very, very soon. You've got something to think about whilst you're waiting if you want to. Here are my footprints. How fast was I going? These are my genuine footprints from the sands from a few weeks ago. How fast do you think I was going during that? Some things you might want to bring with you today to help you join in the lesson. And feel free, if you are not doing either of those, to head over to Facebook, where I'm going to put a little space where you can say hi, which I've not done yet. I'm going to do now. And like and subscribe. Or, you know, anything, really. Yeah, do what you want. Right, I'll do the post. Okay, you should be able to say hi now. There's space. There's space to say hi. Okay. Oh no, my paint's dried off. Okay, I'm going to be a little bit longer because I've got to go and get fresh paint. Thought I have paint. I'll be 2 minutes, guys. 2 minutes. Right, okay. Paint that I can actually use. That's always helpful, isn't it? Dried paint, no good. Wet paint. I should have said something to dry your hands off with or clean your hands with as well. I realised. I forgot that. Oh man, I just put a chair on my toe. Oh, ouch! That's the right word to use live on YouTube, isn't it? Ouch! Good morning, my prof! How are you doing, guys? It is still morning, just. It's Friday. It's 11:37 according to my computer. I'm Ruth. This is Joyful Maths with Ruth. This is my all ages maths lesson where we are looking at maths in dinosaurs this half term as voted for by you. You asked me a load of questions. I said I'll use maths to answer them. I can't tell you how many questions I got about speed. It was a lot. So we had to dedicate a lesson to dino speed, which is what we're doing today. Now, So last week was rubbish for me. I was off work because I had a funeral. Then I got really ill. So you might be able to hear that my voice is a bit, and I'll probably cough quite a lot. I'm actually better, but I'll just keep coughing. Can't get rid of that bit. Right, before I come to you had something to think about. You saw my feet going across. These are my hands, but you know, pretend it's my feet. I'm doing it with my feet too. You saw my footprints in the sand. And I said, can you tell how fast I was going? And the reason is, one of my favourite questions that I got asked was, can we tell the speed of a dinosaur just from the fossilised footprint? Let me try that again. Can we tell the speed of a dinosaur just from the fossilised footprints? And I thought, yeah, of course we can. And then I went, wait, how? I realised I didn't know how. And I was like, ooh, this is fascinating. So that hence the start. We need to think a bit about this, though. We need to think a bit about speed before we start answering this question, I think. So if you want to do this with me, do. I'm in a really small room, so this doesn't work brilliantly well, but I will get up and demonstrate because I can't resist, because I don't like, if I can not sit still, that's always the option I'll choose. So what we're going to do, you're going to go to one side of your room. My room is tiny, so it's there's not much to do in it. But we're going to start off, and we're just going to walk from one side to the other. And then when we get to the other side, we're going to run back the other way. And you can test it a couple of times if you want. You can walk back again. I don't know why I have to swing my arm. I don't usually walk like that. And then we can run back the other way. I can't get much speed up because I don't have much space. But, you know, you might have more space than me. And I want you to tell me or have a think about what has changed in between those two. What's different between when you're walking and when you're running? Apart from the direction, because I told you to change the direction. Although we could, you'll send me off on a tangent if I involve that, because we start talking about velocity instead of speed, which is very similar, but it's got direction. I won't do that today. I won't do that. What has changed between those two things? What's changed? I'll give you a chance to have a little think about it. And then, because you can't tell me on this one, I don't have comments on this one, but I do remember what people said on Tuesday on Facebook when I did this lesson, and I'm going to use those responses to talk to you about it. What has changed between those two different things? So some people noticed that the speed changed. So when I was running, I was faster than when I was walking. Some people noticed that the time it took me to move from one side of the room to the other changed. So when I was running, the time was shorter, and when I was walking, the time was longer. Some people noticed the stride length changed. I don't know why I can't use my arms. This is not a stride length. This is my arms. Stride length. The distance between my feet landing on the floor was bigger when I was running and shorter when I was walking. All of these are going to be so important today. Another thing that somebody asked me almost immediately on Facebook, like it was the first question that I got asked out of a lot of questions. How tall am I? Me. And what is the how long are my legs? So I measured them for them so that they could have a think about that. I measured my legs, and I've forgotten what the measurement was now. So I'll tell you, just in case you were thinking the same thing. I think it was to do with that first question. Measurement of my legs. Okay, so I'm going from the bottom of my foot up to my hip. 33 inches, which is about 84 centimetres. 33 inches, 84 centimetres. I think they've got longer. Oh well. Oh, maybe it's because I was standing differently. Interesting. Right, let's have a look at this then. Let's link this to a bit of maths. Because straight away my brain went to this formula when we talk about speed, because this is a really common formula used for average speed. It presumes you're moving at the same speed, that you're not speeding up or slowing down, which is difficult because that doesn't happen in real life very often. So we have to often model very differently. But constant speed equals distance divided by time. So when speed changes, it is actually down to these things changing. These are called variables. So the distance is a variable. We can make the distance longer. We can make it shorter. The time is a variable. We can make it longer and we can make it shorter. And both of those have an impact on our calculation for speed. So when we were running across the room, the distance didn't change. The distance stayed the same. The time changed. The time changed. It took less time when I was running, and that impacted on the speed. So because the time changed, it impacted on the speed, even though the distance remained the same. But what is the problem with this formula, using this formula and linking it to dinosaurs? Why can't we use this formula specifically with dinosaurs? And this problem's come up a few times in this series of lessons. Same problem going over and over again. Why can't we use this particular formula, speed equals distance divided by time, with dinosaurs? What do we need to do? What do we need to do to work out speed using distance and time? We actually need to take some measurements. We would actually need to be able to see them run and measure the distance and time the time. Can we do that with actual dinosaurs? Of course we can't. They are extinct. Well, apparently most are extinct. There's the whole evolution into birds thing, but you know, like the dinosaurs we're talking about, like ancient prehistoric dinosaurs, we can't observe them. We can't actually take these measurements. So that's no good. We absolutely couldn't work out how a faster dinosaur is in traditional ways, in the ways we would work out how fast a cheetah runs, for example, because we can actually observe a cheetah. So what we need to do is we need to look at things that are around nowadays that are actually alive that we can observe, and we need to look for clues. Why is that a clue? That's not a clue at all. I don't know why I did that. Clues. Let's pretend it was a magnifying glass instead. Oh man, I'm in a silly mood. So what other clues could you look for in my footprints that would help you tell how fast I was going? So what other clues, what other information would you need to know? Mathematically speaking, this is such an important question when it comes to real life and problem solving maths, because we need to actually work out what information we need to know in order to answer the question first. We're not just given it. So we're looking at this. What other clues came up? One of them was the stride length. If the stride length is further apart, we could probably assume that I was running. But as other people pointed out, they didn't know how tall I am. They don't know how tall I am. They don't know how far is between my feet. So actually knowing how tall I am, what my normal stride length is, was important. And I believe the person that was asking how long my legs are were comparing it to their legs and working out their own stride length to try and work that out. Absolutely genius. Compare it to something you actually know. So a really good clue is definitely the stride length. Other really good clues that we might look for is the footprints themselves. So if you look at these footprints, what do they actually look like? How much impact is on the ground? You might have noticed, you can see my heels are quite dug into this ground here, which I was actually walking here. I was walking. So I wasn't walking really slowly, but I was walking, not running. If I was running, this footprint would look very different. My toes would have gone into the ground much, much more. That's really helpful. We know that because we're humans. We have similar feet to each other. We've seen human footprints before, but we actually need some more information about dinosaur feet in order to be able to look at the fossils to do that. So there's a really amazing zoologist called Robert McNeill Alexander, a British zoologist in the 1970s. He came up with a very good formula for using to calculate speed of a dinosaur from the fossilized footprints. And I was like, yes, awesome. We're going to do a lesson using this formula. La, la, la. You take a little look at this formula and you'll probably see why. It was quite hard to think of what we could possibly do with this. It's quite a complicated formula. Okay. So we've got V is the speed of the locomotion. So speed of the animal in this case. G stands for the gravitational pull of the earth. H stands for the hip length or the hip height. and SL is the stride length. So here is the formula that Robert McNeill Alexander came up with. It was V equals 0.25 multiplied by G to the power of 0.5. SL, stride length, to the power of 1.67 times by the hip height to the power of minus 1.17. And even that, people questioned. People said, wait a second, we can't tell the hip height from a fossilized footprint, Robert. We can't tell that. And he said, actually, the hip height can be estimated from the size of the footprint, because actually our bodies tend to have different proportions that link to each other. So you might find for yourself, you could test this, that your foot, if you put your foot up, you have to be quite flexible, and put your, what's it called? Heel by your elbow, your toes will pretty much reach your wrist. So there's things like that we can use of our bodies. And that formula actually turned out to be pretty good. It has been modified though. It has been modified over the years, and they've used that to calculate estimated speeds of dinosaurs. Okay, so we're going to dig a little deeper. First of all, we're going to look at some animals that we can actually observe. Okay, we're going to look at some animals that we can actually observe. So you may be aware, cheetahs, fastest land animal on Earth. Yeah, fastest land animal on Earth. They're not wildly different to lions. There are differences, there are similarities. Cheetah is faster than a lion. Just looking at these two, just looking at them there. What features do you think maybe make a cheetah faster than a lion? What features might make the cheetah faster than a lion? Because they are faster. I'm going to give you a second to think about it, and then I'll tell you some of the things that people said to me on Facebook. Okay, so there's quite a few things here, isn't there? Maybe not. Lots of people notice that the lion is denser. It's a bigger mass. It's got a bigger mass. It's probably weighs more than the cheetah. You can see the cheetah's much slimmer. So they predicted that the mass might have something to do with it. Some people notice because it's slimmer, it's also more aerodynamic. So going to move through the air better. Some people noticed that the tail looked more muscular and would help with balance as it ran at speed. These are all really, really valid points. And the other thing we're going to explore now, we're going to explore what about this leg length here. You might notice the cheetah's leg length and the lion's leg length in proportion to their bodies is quite different. Okay, so I asked you to bring some paint and some paper and something to like wipe your fingers off with afterwards. Okay, you need two different color paints. It doesn't matter what color. I've got orange and blue today. We're going to start off pretending your fingers are a cheetah. We're going to use your pointer finger, this one that's pointing at you there, and your thumb. They're going to be your cheetah legs, okay? And we're going to choose a color of paint. I'm going to choose orange. You're just going to dip your finger and your thumb in that paint. So you've got some on you. And then we're going to run across our page. I'll show you how. I know what you're thinking. Which bit of the page, Ruth? We're going to go diagonally across, okay? So we're going to have a cheetah running across our page. Let's just make sure we've got space here. Let's move you back. Come on. Okay, you ready? Cheetah running across. Okay, there's my cheetah. And what I forgot on Facebook, because what sort of maths teacher does this? I forgot to do a key. I should do that. So orange on the label as a cheetah. Okay, so that's my cheetah. Cheetah. Oh man. Spelling and writing upside down. It's just not my forte. Okay, then we're going to do a line. So that's your cheetah. So you're using your thumb and your pointer finger to run across the page, and we label that one as a cheetah. And then once you've done that, we're going to do the lion. But for the lion, we're going to use different fingers. So I'm going to show you these fingers very carefully. Very, very carefully. We're going to use a pointer finger again, and then our middle finger. Pointer finger and middle finger. And these are going to represent our lion. So we're going to dip those in a different colour paint. I'm using blue for my lion. So blue, and we're going to run across the page, starting at the same point, run across our page as a lion, and then see what happens. See what we notice. Okay, so starting at the same point, and we're going to run across the page as a lion. Okay, and that's my lion. Better put a key on again, eh? So blue, it's mixing with the yellow I used the other day a little bit. Blue is representing my lion. Okay, that's the lion. What do you notice about those? What's similar? What's different? Why might that impact the speed of the animals? Okay. What do you notice? I'm going to give you a little second to look at that, have a go yourself, see what you think might come up, why that might impact the speed of these animals, why the cheetah will be faster than the lion. I don't think. So lots of people on Facebook noticed sort of two key things. One was that the stride length of the cheetah was longer than the lion's. And the other one was that the lion had to take more steps to reach the same distance. It had to take more steps to reach the same distance. And that is spot on. That does actually impact on their speed. It's to do with the energy efficiency and how fast they can run and how fast they can move. Is this leg length, this length from the foot to the hip height. So the cheetah's hip height in proportion to its body is much higher than the lion's. So this one you can see. I've tried to make it obvious on there. It's not a brilliant picture because they're not actually, cheetahs are actually smaller than lions. But, you know, in proportion to their body, the cheetah has much longer legs. It means it can make bigger strides when it's running for the same amount of energy. So it can use the same amount of energy to make much, much bigger, longer strides. And those longer strides make it faster. So, actually, there was a study on this. There was a study relating exactly to dinosaurs at the University of Alberta in 2016. The study was on leg length in carnivorous dinosaurs, so ones that ate meat. And they found a formula. They created a formula that showed adaptations for speed. And the theory comes down to essentially that carnivorous dinosaurs got bigger as they evolved, and they got bigger in order to develop bigger, longer legs to make them faster. So the bigger they got, the faster they got. So I showed this picture before. This is not a T-Rex. This is a T-Rex. And over millions of years, it evolved, and it evolved into a slightly bigger animal, and then a slightly bigger animal, and then another slightly bigger animal, until it became a T-Rex over millions of years. So most animals do that. Most animals evolve and get bigger over time. And the theory from the University of Alberta in 2016 was that they do that to get longer legs, and that makes them faster. Okay, so I was like, great, bigger animals equals faster. So if we look at this, why is an elephant not faster than a cheetah? Because look at those legs. Look at why than a cheetah? Go on, tell me why it's bigger. It's got longer legs. Why is this elephant not way faster than a cheetah? Based on that. What would you say? What would you think? What features? Have a look at them now. If you've got the workbook, you can do this in the workbook, but you don't need it. What features mean that the cheetah is going to be faster than the elephant? Have a little think. It's a difficult one, isn't it? It's a difficult one. Some people quite clearly said, like the mass of the elephant is a problem. Like the size of it, its weight is a problem. So I suggested you bring something heavy with you that you wouldn't drop. I totally forgot to do that. Again, I actually forgot on Tuesday too. I'm gonna pretend this book is super heavy. It's actually not. But like we're gonna have a go at this guy. So remember what it felt like walking or running across your room. You might want to test again. Just have another little go. And then pick up your heavy thing. Pick up your heavy thing and try again. How does it feel running across? Actually, even with just the book, how does it feel running with that in comparison to running without it? How is that affecting how you run? I actually don't need to imagine this because I have 2 children and I remember the difference between running on my own and running carrying all their stuff. And that gave me a good idea of what it feels like to be maybe not an elephant, but a donkey maybe. Or a camel. So there's an issue here, isn't there? There is an issue because it's all well and good saying, right, longer legs are going to make us faster. And certainly there's probably a bit of it in there. Like somebody that's taller than me probably has an advantage when we're running against each other because they've got longer legs. But there might be other things that hold them back. And one of the things is weight. Because the bigger dinosaurs got, the more they weighed, which meant they weren't necessarily faster than ones that are smaller than them. Actually, when we look at it, there's a bit of an issue because actually it's more to do with the proportion of the leg length with the animal itself. So with the cheetah, although its leg length is shorter, it's a bigger proportion of its overall body than the elephant. The elephant's is a smaller proportion of its overall body. That cheetah one should have been red there. I did it wrong colour. So the cheetah's actual the proportion of its leg length is much longer than the proportion of the leg length of an elephant, which gives it a bigger stride, but also it doesn't carry as much mass in proportion as well. So it's actually much more complicated. There are way more variables than just the stride length. We have to look at the mass. We have to look at the aerodynamics of that body as well. So using all of this, scientists believe that the fastest dinosaur, and some of you wanted to know this, they believe some of the fastest dinosaurs were Gallimimus dinosaurs. They estimated the speed they could run at to be 42 to 56 kilometers per hour. This is what we reckon a Gallimimus looks like based on fossils and other evidence. Maybe a bit like an ostrich-like bird in build and size, but because of that very, very long legs, but quite a lightweight body, so not a hugely heavy body. And obviously we can use ostriches today, which are very fast animals, to compare that to. Velociraptors, we've seen a lot about velociraptors being fast, but because they were super small, they were only actually the size of a chicken. They were really, really tiny animals. It's actually quite unlikely that they were super speedy. It's more likely that although they were probably quite fast for their size, because they were so little, it's unlikely that they were the fastest dinosaurs. And actually T-Rex, they reckon grew super big, like too big to be really fast. Although it wasn't super slow, it was like one of super slow dinosaurs. They reckon its mass in the end, it ended up being too big to be one of the fastest dinosaurs. Slowest dinosaurs, what do you reckon? I actually think this is worth having a guess at, because I reckon you could probably guess what the slowest dinosaurs were, or the group of dinosaurs that were the slowest. Have a little think. I asked on Tuesday, and most people were like, yeah, we're totally on this. What do you think the slowest dinosaurs were? Any ideas? I may have done, if you've done all my lessons, you could probably, on dinosaurs, you could probably think back to the first one on the biggest dinosaurs. Lots of people said to me things like Diplodocus. And you're not like, that's very specific. I was thinking more like a group of dinosaurs. So I said sauropods. Sauropods, you might have said titanosaurs, which were a particularly big group of dinosaurs, but they reckon just due to their absolute massive size, they were probably quite slow. They relied on their size to provide defense. They didn't need to run away from other animals, and their huge long necks to get to food, so they didn't need to run after anything. They didn't have to hunt prey. Okay, we're gonna have a little quiz. I like to mix quizzes up and make them a little bit different. So this quiz, what we're going to do, I'm going to start off with a scenario about running, and then I'm going to ask you some questions. There's going to be 3 questions, and you're going to guess slower or faster. Slower or faster, okay? So I'm going out for a little jog. I do occasionally. I call it a shuffle because I'm not very fast. I'm going out for a little jog. As I move along, I'm going to change some things. Will I get faster or slower? Okay, so I'm going to start off. I'm going to stretch my legs out further. I'm going to stretch my legs out further. Do you think I'll end up going faster or slower? And you can answer this any way you want. You can shout at the telly. You can just think it. You can write it down. You can put it in your workbook. You can do whatever you want, really. Faster or slower if I stretch my legs out further? Okay. If I pick up a heavy bag, am I going to go faster or slower? Okay, and finally, I'm not going to change anything else, but I'm going to run for twice as long. I'm going to run for twice as long. So when I say twice as long, I mean like twice as long in terms of time and distance. So I'll double my distance and double the time it takes. Okay. Let's have a little look at these then. So I'm running along, and then I don't change anything else. I just start striding out further. So for each step, I'm taking a longer step. I'm hopefully should go a bit faster because each of those steps is going further. So hopefully that should make me faster. Then I've got my kids have decided no, can't carry that anymore, and I'm like, oh gosh, okay, I don't want you to leave it there, so I'll do the good thing. I'll be the lovely mum. I'm going to carry it. Oh yeah, and you want me to carry something, and yet you're done with your scooter. So I've picked up lots of heavy things, but I'm determined to keep running. Am I going to go faster or am I going to go slower? I'm going to go slower. It's very likely I'm going to go slower. I could keep up the speed, but it's highly likely I'm going to go slower. And then I think, oh, right, I'm putting all those down. I'm done with all that. Right, okay, I'm going to carry on running for myself again. And, I'm feeling good. I'm feeling good. After 5K, instead of just doing 5K, I'm like, nah, I'm going to do 10K. I'm going to keep up the same pace. I'm feeling really good. Am I going faster or slower? That was a bit of a trick question. Because if I double my time and my distance, actually my speed remains the same. if we go back to the formula here, speed equals distance divided by time. If I change the distance and the time, and I change them in the same way, so I double the distance and double the time, actually, when I do the divide, I end up with the same speed. I end up with exactly the same speed. So that was a little bit of a trick question there. A little bit of a trick question. Okay, that is it for today's lesson. Thank you so much for joining me live. You can go to Facebook and say hi if you would like to say hi and you'd like me to say hi back. If you haven't got Facebook or you don't want to do that, I still want to say hi to you. Hi, guys. It's awesome to have you here. If you want to do that, that's your chance to do that now, whilst I do my little spiel, because although these lessons are free, I do get paid for them by lovely people signing up and supporting £5 or £6 a month. That's how I manage to do these lessons. That pays my wage. So that money is literally for the time I put into these lessons and delivering them. As a thank you, I do send to supporters these little activity books. So this one's all about fractals and hands-on ways to explore it. It comes with some really beautiful origami paper and some stickers that I have designed. And I it's so close to getting my weather one out. I now have the stickers and the freebies. I just need to send it off to get printed, and that should come out this month, definitely. So that'll be coming out to anyone that's supporting me, and anyone that signs up in the next week or so, definitely. Oh, excuse me. Right, say hi. I've got to say hi. Let me get it up on here. Find my post. Where are we at? I've worked out how to get the newest comments up. Woohoo! Okay, we got some highs. Nice to have some highs. Hi, Isabel and Thomas in Tenerife. Cool. I bet the weather's better in Tenerife than it is here. How are you having? Are you having a good time in Tenerife? That's what I want to know. And what's the weather like too? I'd like to know what the weather's like. Sounds lovely. I wish I was in Tenerife. No, I don't. No, I'm enjoying being here. Maybe I wish I was in Tenerife. I could do this lesson from Tenerife, couldn't I? Yeah, I could do this lesson from the sun. I could totally do that. Okay. Oh, Bella and my cat tights. They have tails. You have tails on the back of your tights. Oh my gosh, that is just too cool. I'm going to show my daughter those because she'll go mad for them. Look at those. Aren't they cool? Whoa. I absolutely love those. They're really cool tights. Oh, loving the lesson. Thanks, Bella. Loving having you here and seeing your tights. They are very cool. Oh, hi from Aurelia again. Hi, Aurelia. So cool to have you here too. Very nice to see you. Right, let me do one more quick. Refresh so that I don't miss anyone. Oh, okay, here we go. Hi, Bonnie and Rafi. Rafi, you're laughing at my running animal sounds. I know Bonnie and Rafi, so he's actually allowed to laugh at me. But, you know, I might laugh at you next time I see you, Rafi. It's lovely to have you guys here too. Oh, you've been here for a month. Okay, right. So more about Tenerife, just in case you're as interested as me. Been here for a month and it's too hot. Finally down to 27 degrees now. You're off to Fuerteventura on Tuesday. Wow. Okay. Yeah, I can't handle too hot. 27 degrees even sounds too hot for me. Okay, maybe that is a bit too hot. Have a nice time in Fuerteventura as well. I hope you'll join from there. I want to know about Fuerteventura next week. Okay, guys, I'm going to say thank you so much for joining. You can hear probably that my voice is going now. I need to stop talking. Thank you so much for joining me, guys. It has been lovely seeing you all, and I will see you all this time next week. Either this time next week or on Tuesday live on Facebook. Thank you so much for joining me, guys. Bye for now.